Please welcome LiveRamp Chief Architect, Canon DR.
Thank you. Thank you all. So, hi, I'm Kanan. Okay, yeah. So, yeah, we heard a lot of AI related stuff the whole day. So, this now I'm going to talk about more on scale, right? How do we, how much we can scale with SingleStore, what kind of load we can handle, how big the database can be, right? So, by the way, LiveRamp, we started using SingleStore. I'm going to, go over the whole journey, in a format where actually, like, what are we solving? And why are we solving and how we are solving it actually, right? How are we doing it? So I'm going to go in that format actually. So let me start with introduction to LiveRamp. LiveRamp is an identity provider in a high level, right? So we provide primary key and foreign key for all the customer touchpoint data, right? So you have different customer touchpoint data from different sources, we connect them, right? So in an ad space, that's a huge deal, right? So we connect between advertisers and publishers, and we provide them, with the security and all the separation of the data, and we provide the connectivity part of it, right? So this is we have been dealing with top Fortune 20 companies, all the top retailers, so the huge customers. Our current data size, the problem we were trying to solve is 100 petabyte, and our current ecosystem is like around 90,000 processors and 300 terabytes of memory, and such a huge setup, right? So we even with that, right, we've been dealing with a batch process, right? We are dealing with only aggregate data at this point. So our requirements have been changing, right? So our data growth has been tremendously growing actually, right? When we started this journey, it was 60 petabytes. Now I'm close to 100 petabytes. So we've been dealing with aggregate data. So we got segmented data, pre-segmented data, and we're trying to connect them. Now, with the collaboration use cases and other use cases, our business was changing more towards event data. So you guys dealing with data know that aggregate data and event data is like multifold, right? So how do we get prepared for the event data? So that was the task. That's what the problem we were trying to address, right? And our customer, we developed our solution, current solution, in 2011 kind of thing. During that time, big data was the only way we can handle huge data set. Right? So we were using batch processes and processing huge set of data. So, but with the current things happening right now, that SLAs we had before was not good enough. So we want to improve the SLAs. How do we make it faster? So the problem is we have to reduce the cost, we have to make it faster, and so all of that, right? Actually, so how do we do it? Actually, how do we make it faster? How do we handle more load, and how do we make it cheaper? So that was a challenge given to me when I'm took this position in LiveRamp actually, right? So this, for my earlier comment on this is what we are trying to solve, right? So why are we solving it, right? So we want to build one data collaboration platform. Initially, we were like identity provider. We enabled customers to collaborate, right? And later we grow into a business of how do we assist our customer to collaborate. Now we recently acquired a company and stuff. We are trying to own the whole stack of collaboration, right? So when we want to do the whole collaboration stack, our business is changing. It's not just batch processing or just not processing the data in the back end. How do we make it more efficient to collaborate? For that, our footprint has to be smaller, and it has to be across cloud, and we want to go where the data is. So the whole dynamics is changing. So this is why we are trying to solve what we are trying to solve, right? So, and when we started thinking about it, so one other thinking is like we are not a pure software development company and selling software. Instead, we are solving customer problems. So we don't want to be going and developing something for a database, right, or a streaming solution. So we thought we'll harness the power of the industry's innovative technologies. So we said, okay, what is industry doing? What is the innovative technology available which we can use to build our solutions better, right? So that's the best way to do it now, right? So how do we get there? How do we find the right technology to solve our problem? Right? So now, okay, as a database guy who has been in the industry for 30 plus years, I know the landscape is huge, right? It's so much there, so many systems there. How do I find the right one to solve my problem, right? So that is my next big challenge. Okay, God, a lot of options, a lot of things. Every database I talk to, every database person, they said, oh, I will solve for everything. Okay, is it real? How do I get it? So I'm a crazy objective guy, so I want to go and dig in detail to see what works for me. So okay, now I started narrowing down a distributed database which can deal with my scale, like 100 petabytes, right? What a petabyte scale, then I filtered out a lot of things. Said, okay, can I do with this? What kind of database I should be using it here? Yeah, my requirement is like this picture here, right? I want everything in one thing, right? So I can't I can't have each one for different database. I can't convince my CTO to say, hey, I'm going to have 4 databases, right? So it's not going to be easy. So I want one. So how do I get there, right? So I spent some really months, going in detail on, trying what is the, to figure out how do I objectively get to my requirements and my needs. How do I find the solution that can help with my needs, right? So I started putting together multiple spreadsheets and I going on different databases and different features. But is all the features means the same thing to me? Not really, right? So for me, certain features have more weight. Certain features I don't care, right? ANSI SQL, I want to be the highest weight for that. So I created okay, I started putting weights on it. Okay, each feature. What is the weight for means for me? It changes from person to person, problem to problem, right? For some problem, a simple Cloud SQL or a simple RDS should do, right? There I don't have to think too much. Okay, you know what? Put it in there, make it work. We are good. For some problems, it's different, right? So we have all sort of problems in our. Say we have a transactional thing because we are having a pixel serving load where the pixels get served from browser, which has to be responded in milliseconds. How do we deal with it? So that's a different problem. This batch process is a different problem. We are moving, of course, we are also moving into AI side of it, where vector search is a huge thing for us. So all different type of requirements we started putting together. By the way, I have what I've done. A lot of people started asking, why did you choose? Why did you choose SingleStore? That question kept coming. So I put it in a website. I put all the parameters in there. So this is a link there. It's like simple compare.db.expert. So this is something in a simple UI. It's not to focus to any specific database. You can use the same objective model I tried on this website. So you can choose your own databases, choices, your own features, whatever you need. Try to put the weights for you and figure it out, right? So you can try that, right? So this is how much objective we went through and choose. We did some POCs and we took we used an hackathon. LiveRamp is into hackathon a lot, so we used an hackathon opportunity to. We had a few database filtered out, and we used that databases to do a hackathon to solve a customer problem, right? So that's where we were able to decide on this. But even though we have all this objective data, all the detailed data of research and everything, we present this in multiple places, but still there will be a question, okay, why did you choose it? They don't want to go look at the objective data. For them, I say, hey, you know what? I spin the wheel. Because, all the objective data, sometimes it doesn't answer people enough, right? So I said, you know what? I spin the wheel and selected SingleStore, right? So, because they don't want to look at the objective data sometimes. It's okay. So I have answers for them too. So, okay, how did we solve it? Okay, so we have a SingleStore as a database, and this slide I'm going to spend some time in there. This is what the main content, I think, in a way, right? So you guys may know SingleStore as a memory database, okay, as a transactional DB, and as a high-speed database, right? So far, that's where I also used MemSQL in one of my startups in an IoT area to as my broker's database to load my IoT transactional data, right? I used it. I know it good with the in-memory side, right? Now I made a choice to use it in my batch process on a petabyte load, right? How does it work? How is it really? So that's what I'm going to cover in this how part. So when we are evaluating different databases, I was looking at them in different features. Where I was not even looking at SingleStore because I know it's an in-memory database. I used it; it's good, but I never thought it will be good for this load, right? So I never even think about it, and I was just okay. I was looking at different databases. I was like, oh, big data database. What is the Cassandra replacement? That type of thinking is what I was going after because the data is huge. Right? So that was my thinking. I was looking at that place. But at that time, I was looking at a video where Raj was talking about object store support and how SingleStore, the name, and how it's you guys know Object Store, right? Object Store is basically S3 and GCS in Google. So where you get connected connect to a database, which you get an bottomless and unlimited storage there, right? So when that I saw the video, that changed, that clicked, right? But at the time, during the middle of the hackathon, actually one of the middle of the hackathon, we were trying some other things. That's when this triggered me. And Chris here, he came in and helped me with the single store details, and he started providing me data, and then I started trying it. So that object store support changed single store in a bigger way. So being a memory database, working with a disk, but with the support of object store, the whole dynamics of the sorry okay, well, the dynamic of the database world itself is changed, I think, because now I can have huge data set at rest in the GCS structure or in the CS3, and then I can use compute and disk to process the data. So that separation and that bottomless feel of that one, helped me solve the problem. So now I was able to do a POC on handling one huge data set, and that really worked. Okay, so I was able to get a 50 billion record table, join with another 48 billion record table, and I was able to get the output in seconds, right? So that worked. That gave me, okay, you know what, awesome. Now how do I take that and attack the petabyte of problem, right? So it is not an easy task, because our company is with like 400 something engineers, and who are all big data people. They have solved the problem with the file-based approaches forever. So I have to go with objective data to prove that this works, right? So that is where we said, okay, now the one approach I was taking there was like, domain partitioning. So I started defining a domain. Okay, so domain definition is here like, hey, you know what, it can be one customer or one set of customers or even a region, right? So I started defining the domain. Okay, and then I partitioned the whole data by the domain. For me, it was audience. It was my audience data was my domain. So for each audience, I said I will keep one audience as a one domain, and I solve it for that. Right? So that was a huge set of data. We started solving for that domain. Right? So because with that, I was able to have a set of clusters and data in the GCS. I was able to run my query. It's basically it is a publisher, an advertiser, and then a link table, joining table. So 3 tables basically will be joining with each like trillion records kind of thing. Right? So we started running that, and so the idea was to domain partition it. So we don't want to solve it as one big problem. Right? We said, hey, it was not one big cluster that's solving petabytes of data. Instead, I'll say, hey, make it into domain-based problem. So where I go with attacking a few hundred terabytes at a time, like a few hundred terabytes, byte size of the problems. So that was the biggest thing for us actually. Say, okay, when we did that, it opened up. So right now, so we said, okay, we separated out. So we, for example, one audience or one customer's data, we bring it in and we inject through the pipelines. By the way, we are running around 6,000 pipelines now in our ecosystem. So we bring the data in and process the data and flush it to the GCS, and we kept the cluster with the CPU, memory, and disk ephemeral. We got rid of the cluster. The data is right now in GCS. Like that, for each audience or each customers, we had separate GCS structure. We went to GCS folders and created a separate structure for them. So the data started residing in the GCS as separate, out object store for. It's like each customer as one database. So when we are able to do that, and the customers came in and connected to the database, we did a process and disconnected it. Right? It's a batch process. Our load is batch process. So batch process, we run the batch every night or every day, whatever the data comes in for a customer, whatever the cluster available, we connect to the object store, get the data in, process it. As an architect, when I'm thinking it, initially when I was thinking about it, drawing on the board, I said, God, GCS object stores are supposed to be slow, right? S3s are supposed to be slow. How much time it will take to warm up? How much time it will take for me to bring it to my disk and bring it to my memory, right? So I thought maybe it's not okay. When I tried, it was much more faster because knowingly or unknowingly, SingleStore guys did an awesome job in how to distribute the data in the GCS, because when each file is by sharding, whatever the shard structure you have, how you shard your data is the structure of data in the object store. So when I connect that and with the GCS, when I load the data, it was distributed to all the machines at the same time loaded. It's about the bandwidth between my node and the GCS, right? Each one had a separate bandwidth. So it worked awesome. It boom, it loaded so fast, which I was not expecting, right? I was like, okay, I was like not so optimistic about it. When I tried it, it was like super fast. So that said, oh, you know what, this is an awesome thing. Now I can scale. So that is how we scale. In that, we had a GraphDB data come in, and we have another database like opt-out database coming in. So where we say, hey, this is opt-out data, and this is the link table. So we were able to bring in that dynamic cluster, ephemeral clusters up. We were able to connect to our data and process our batch, and then connect to another database which has got the link table, and another database which has got an opt-out, and then we were able to do that. And that same thing we could do it in the different clusters as well, right? So that's how we were able to scale this in a bigger way, and the whole footprint of LiveRamp becomes super small, right? With all this actually, so this is one. So okay, when we are doing all this, we said, okay, how do we move our whole graph, our one of the graph building ecosystem? That is one of the, like as you see, around 10,000 core processors running to do this, our identity graph building stuff, right? So we moved this. Why I'm specifically mentioning this one is like this is one of our biggest cluster, right? One of the biggest clusters running. It's got 6,400 tables with 550 procedures building the edges. So here also the edges, we have the edges and we are graph building, simple single store efficient join with a new stream joining. And as I said earlier, the object store played a bigger role. And the next thing that played a bigger role, which we worked with them very closely in enhancing that, is spilling. When it fills the memory, it started spilling to the disk, right? Specific joins, it started spilling them. So I don't have to keep the whole data in memory to do my processing, right? So that it can spill into disk. That made it economical, that it made it efficient, that made it usable for me to solve the bigger problems. Right? Without that, if I have to go with all memory, that's what the rest of the database are doing. Right? They need to bring all the data to a memory to join and make sense out of the data. So whereas here, the joins and the window functions can spill now, right? So now I'm working with SingleStore closely on every window function, every joining to spill now. So we are almost there solving, it's working with most of our use cases what we need. So that is a huge differentiator, right? When we look at database, yeah, we can go to cloud, we can sign up, start working, most of the use cases that will work. But when you want to solve a bigger problem, we have to go into deeper level like this to solve the problem better, right? So, okay, now this is how we're solving it. Okay, what is happening with what we solve, right? So here I have a director here who got. So by the way, previous slide I want to show something here. So me and my CTO here, Mohsin, we come from energy industry, right? So we always be energy conscious and we think about energy when whatever we do, right? So with this whole change of the graph, right? There is like 6,000 trees, 67,000 trees saved because the whole core reduction, right? There's a different impact too, right? We are, carbon footprint, right? The carbon footprint reduction, I thought, we are bragging about that too because even though we come from energy industry, we are in the ad tech now, we can't let go of that thinking, right? Me and Vasily, we talk about it and that's one of the points I want to mention here, right? So this whole effort led into the carbon footprint reduction as well. So here, this is a data transformation thing, right? One of the bigger pipeline or bigger flow. Previously, it was Spark, Hadoop, and all sort of things. So where in this whole process, a file comes in, and we run microservices on top of it, and each services copies the file every time it processes. Okay, I take the file, do the process, copy it, resultant will be copied to another file, and the next service comes and copies the file. So we had around 30 copies of the file in this one process, right? So with the single store approach, when we move to single store right now, there is one copy. The file comes in, stays in the database. Rest of the operations happens in the database. So we avoided copying files, right? So when we're talking about security and data integrity and all those things, governance and everything we're talking about, it is the lineage and everything was like easy to track for us because now we don't have copies, okay? And the whole footprint reduced dramatically. Right? So this gave us the performance and also development simplicity, developer velocity, all those things. I'll go over in another slide. So here, this is hundreds and thousands of lines of code in this path in the previous world as one SQL, right? One simple SQL statement replaced like literally thousands and thousands of lines of code, and multiple solutions here. Like what, so many things were there. Actually, I don't even want to figure it out. Like so much were there, and it's all gone, replaced with simple SQL statement. Because in a high level, right? So the data is in the file. You want to take up and join the data, and you want to join with a link table. Think about it in a Hadoop world, right? You have to map this thing. You have to bring all the files here, trying to map them, and you have to have an internal link table there. All those things are figured out by data engineers, and doing it in a Spark and paying millions of dollars for the Spark. Whereas in table database world, hey, select, join with this table, keep this link table, join. It's a simple select statement, solves the problem. But why we're not able? Because previously we didn't have a database which can handle this load, the size of the load, or the magnitude of the system, right? So right now, at least with the object store support and other things we have right now, we are able to handle that load. So with that, we were able to simplify this to the biggest extent here, right? So before that, right? So one of the main things is like when we started doing it, I was talking to an technical lead manager yesterday, and she was saying, Kanan, we saving cost, and cost is reduction. It is fast now. It is efficient. Everything is good. But how do I report this? I said, what? So right now I want to troubleshoot my graph. Normally there's how did this come from? Where did it happen? Before, it used to take me at least 2 to 3 days to troubleshoot and lineage in the graph. Now it took me 15 minutes, right? And that was the craziness, right? See, that is a big difference. How do we quantify that? So we're quantifying it as velocity and stuff, but still there are a lot of unquantifiable benefits out of this as well, right? And the development, so maintenance of this code and maintenance of this code. Imagine, right? The whole teams of people maintaining it, and the whole pain comes with that, and the whole easiness comes with the simplicity. You can imagine. So here, right? So now SingleStore is in the middle of everything for us, and now we are solving all our different problems, and we reduce the footprint to the smallest footprint possible. So of course, we are considerable reduction in cloud spend. You can obviously see that, and faster processing and latency. Technical depth, actually, right? With all the things I showed you earlier, it comes with a lot of technical depth and a lot of stuff, but it's more simpler now. And customer stickiness, because we had a project recently specifically done led by our CTO there as a Lightspeed. We went and attacked churn, and we did a considerable improvement in the churn by using this, actually. So that was really proven reduction in churn we have right now, and developer velocity, faster time to market. We are now, with all this, our new collaboration use cases, where we were not able to do before because it's a event data, right? So we are already overwhelming with aggregate data itself, right? We have segmented data, whereas collaboration needs event data. For example, I have a segmented data. I targeted an ad. I sent a campaign. Now I want the event data to know whether the campaign was successful or not, and all those things. That's where the whole cycle ends, right? For that, we were not able to provide fully before. Now we have all the technology to solve that, and we've been solving that. Even today, if you see LinkedIn, we announced our data collaboration platform going live, and it's making a big wave, and this behind it. Thank you.